This video is about how do you start dealing with a problem or a complex problem and issue using system thinking. And why is this important? Because we are surrounded by complex issues. There are many problems in the world. Perhaps you are in practice or doing research and you are thinking about using system thinking to deal with a problem through your research, whether you're a student, a researcher, or whether you're a practitioner or somebody else who is interested in knowing about how do we solve problems using system thinking in particular, and especially for problems that are complex or increase in complexity, then this video is for you. And the material for this video is by a researcher called Hordar Haraldson, from his report called Introduction to System Thinking and Causal Loop Diagrams, which was published by Lund University in 2004. And I've already done two separate videos prior to this one, where I talked more about system thinking in general and properties and things related to that. So it's important to understand. It's very important as a starter, if you've got a complex issue, it's really important to keep in mind that you need to understand dynamic complexity, not detailed complexity. And I'll explain more why this is important. So when we make mental models about a problem and define our system, we need to be aware of the level of details that we are targeting, because our understanding of the system increases to a certain extent until we have added so many components in our mental model, that our performance and understanding decreases due to the complexity of that problem. And this happens because our ability to understand, to grasp the total dynamic of that problem becomes weaker and weaker the more variables that we start adding or noticing and understanding. So the more variables we add, the harder it gets to understand this problem. And when we create mental models, we do not intend to capture the entire reality in one model. These models are as complex as reality itself. But what we want to do instead, which is what Haraldson suggests, is to map part of that reality in a way that it gives us a basic understanding of that complex problem that we're trying to handle using system thinking. As an example, if we are trying to understand car pollution in a city system, going into engine details of that car would only add unnecessary details and complexity and weaken our understanding of the system's behavior on like an average aggregated level. And also we can now we can observe also how systems are integrated into other systems. So this is another important thing to understand. Variables that we choose are subsystems themselves, and their components are also you can think about them as subsystems and so on. So we need to think about that. We need to think about how subsystems are integrated, anything that we observe. And I went through that in the previous video when I talked about cars. You've got the car itself as a system, and then you've got the battery itself, which is a subsystem. And then if you go higher level, then you're looking at an urban system that is linked with the car and so on. So we need to ask, in this case, we really need to ask, do we have variables that are working on several different system levels simultaneously at the same time? So this is important to ask yourself when we are looking at a problem. Because the larger number of variables we are considering, the greater the complexity and our uncertainty around these variables become. And when you are observing, looking at a larger scale system that has endless number of variables and integrates through multiple system levels, like, for example, global climate, in the case of the car, there is a need to simplify that system in the model that you are creating. And we need to generalize and ask a question that confines our system boundaries within determined spatial and timescales. Now, when we are defining the system boundary in time and in space, you also need to look at what Haraldson called super signals. So super signals, he defined them as key components. They are the variables that create the patterns or the feedbacks that we observe from the interaction between these variables within that system that we're looking at. So these are super signals. For example, when we learn to drive a car or to ride a bicycle, we are learning by detecting the feedbacks that we get from steering in different directions, accelerating or also braking. These super signals give us the key variable that we use to move between system levels in time and also in space. They are our key, they are the basic to how we understand the system behavior and also how we classify that system at the same time. Also, when we are defining the level of how detailed our system is, Haraldson suggests that we should select the level needed to understand that interrelationship among what he called our goal variables, which are the ones that we want to influence to answer the question we pose for the system. So when you are having to define that level, then detailed knowledge of the underlying components is not needed, he says. And identifying the system level can be done by determining what features, what components can be collapsed into a single super signal. Because identifying the system level and its boundaries requires great consideration on defining the problem and asking the basic questions that we want answers to. And it also needs a group efforts from individuals that are stakeholders in the problem, involved in the problem, or have invested interest in solving the problem, or maybe they've created the problem in the first place, and so on. So you need to identify the goal variables and their dependencies to understand the causal relationships. And also it is important to identify the hierarchical structure of the variables and how they are embedded both spatially and temporally in order for us to, or for you in this case, to make an accurate hypothesis of the problem that you're dealing with. So this is just a background before I get now into how to start dealing with a problem using system thinking. So it's important to know these basics that I just talked about before I address this question. So how do you start dealing with a problem? Again, as I mentioned, you are a practitioner or you are a researcher, you're a student trying to look at a problem or an issue in society, like say obesity, etc., climate change, whatever it is. You have this problem, or it could be much simpler than that. You have this problem and then you're trying to deal with it and you don't know where to start. So Haraldson gives lots of really useful information on how you can start building up a picture and understanding that system that you're dealing with and understanding that problem and the levels that you're focusing on. So let's talk more about that, about how do we sort the problem. So system thinking starts by defining a problem. Defining a problem often needs group work with relevant stakeholders and problem owners. After specifying the system boundaries of the problem and focusing the question, all the key variables relevant to the question are listed. So you need to list them. So in my project, for example, in my PhD, I started with this. My whole PhD was about identifying the variables and listing them. And I worked with stakeholders, and in this case, different members of the public to actually list and understand and list these variables or factors. Then Haraldson says that ideally, after you list these variables and after you've worked with the relevant stakeholders, you need to, and maybe you could, by the way, you could do, it might not be just one session, one, say, group session or interviews. It could be multiple exercises that you have to do in order to get to understand which variables you're looking at, which ones do you list. So that process in itself could take a while as well. Just keep that in mind. By asking one group of people, one strand of stakeholders, you most probably won't get the full picture of a complexity of a problem that you're handling. And ideally, Haraldson says that the variables relevant to both the question and the answer to the problem should be discovered during that process that you're doing. That brainstorming sessions or interviews or whatever that you're doing with different stakeholders. The variables should be sorted according to spatial and also time influence, where the hierarchical system levels that you are discovering are being placed. And it is important in here to distinguish between what components, what system parts are interactive within the system internally and enclosed by the system boundaries, and the components that are outside the boundaries but influence on the system externally. Okay, so that's an important point because I will get to an example in a second. So let's take the example. So just to let you know, Haraldson used a different example. I'm using a different example to the one that Haraldson included in in this report, but it's a close one. So let's take the example of water consumption. Okay. So you ask the question, for example, you have a problem. You ask the question regarding this issue. How do different alternative water management reduce water consumption? So you're trying to figure out how do we reduce water consumption in general, maybe in a local area, on a local level, regional level, or whatever. Okay, so that's your question, that you define the problem. Okay, so I'll repeat it again. How do different alternative water management practices or management itself reduce water consumption? So let's look at that. So I listed here, and this is inspired by the example, another example that Haraldson gave in his report. So I've listed here some internal variables that you could see. You've got internal variables that are, as I just explained, they are interactive within the system, they are internal, and they are enclosed by the system boundary. And also other components that are outside the boundaries but influence on the system. So these are external variables. Okay, so you've got some internal ones. Some of here I listed here. I'm not a water person. You got to keep that in mind. I just jotted, some in here. You could maybe do your own kind of drawing inspired by this slide to come up with your own. So I've listed capacity, I've listed recycling, water recycling, that is. I've listed quantity, I've listed bills, personal experience, existing practices as some of the internal components that might come up, that might show when you are talking to stakeholders. So these are internal variables, okay, that are interactive, that are right there. You can see them, you can figure them out, you can list them with stakeholders. And they are within our system boundaries that we're looking at. But maybe you've identified other external variables outside of the system boundary. These could be costs. They could be related to policy, rainfall levels, population growth. And there are also ones that sit outside that, you kind of jotted down. They're kind of, you could see some sort of interest or people mentioning them, but they're sitting kind of outside. Nobody's mentioning them directly, maybe directly, who knows? So, and I've listed some of these. Again, these are just made up. So I listed them. So you've got water scarcity, outlook. You've got climate, education, aquifers, water sources, groundwater levels, dams, and so on. Okay, so you've listed these on the outside. So what Haraldson says is that a system then, after you've done this exercise, a system then can be sorted in time and space in order to help you to focus on where in the problem your effort should be put. Okay? And he has got, I can't copy paste the same diagram that he used because there could be copyright implications here. So my apologies, you can go to the report and see them. But I've kind of did something similar using my example to show that you can sort these variables that I just talked about using that made-up example into by time and also by space to help you out, to help sort the variables for you and help you focus where your attention should be put. And you've got by time, you've got months, you've got years, you've got decades, and then you've got the size of the system, which is the spatial influence element of it. And you can see here, I've listed, things like capacity by month. The variables that are relevant here could be the capacity, the water capacity, the bills, people's bills, consumption, how much people are consuming water per household, or per neighborhood, whatever, whichever scale that you're looking at. And then you go to years. Maybe you want to look at recycling within a year. Are we recycling water in any way? Are we just chucking the water itself that we're consuming? Maybe you want to have a look at the rainfall within. Maybe you're sorting the variable into rainfall variable into the number of years. How much rain are we getting versus how much are we consuming? And so on. And you've got policies, and then in terms of decades, you've got climate, you've got population growth, which is the anticipated population growth, and so on. So you could see here, using the example of water consumption, our driving force here is the consumption of water on a monthly basis, but it is influenced by rainfall levels on a yearly basis, year by year basis, and population growth that increase water consumption. This helps us to choose our limits and observation timescale. But if stakeholders raise the issue of, say, people, maybe some in your a group session raise that some people will have a backlash if you start implementing. If you are trying to implement a policy that would reduce, water consumption, you might have a backlash. So backlash is a variable. It is a variable that could affect what you're trying to do. So in this case, you might think about education as a variable that you want to focus on. And in this case, the time scale is different in terms of what you target and your plan, because education could take decades to reach that level, where people maybe they might accept reducing their water consumption on a daily basis. So you can see here that problem is really a very complex problem of asking a question of, can we actually use alternative ways to reduce water consumption? And it is something that could actually happen in our daily life nowadays. It could be something valid because there is a scarcity of water. There's a lot of pressure on drinking water or water in general. So you never know, it could happen actually. So these are the sort of things that these are the steps that Hudson suggested that you could do to classify your issue, to define, your problem, to have a look at the variables, list them, sort them, think about the levels, think about the boundary that you're targeting, think about the time and the size of the problem that you're trying to target. So think about time and space. And then after you've done all of these things, then you can start to focus your efforts on the areas where you could make a difference, your goal variables in this case. So I hope this video helped you in understanding all of these things, and definitely have a look at the previous 2 videos because they give you introduction into using the same report by the same author into linear thinking. So I started from the beginning, from scratch, talking about linear thinking versus system thinking, mental models, our boundaries, and I moved on to feedback, and then other things as well in regards to explaining the system levels, the structure, and so on, and behavior as well. So, and I hope this video has helped you as well continue that conversation.